Okay, next lesson is covering volume of a pyramid. Now you got to remember what makes up a pyramid. What makes up a prism is having two bases. Okay, so for example, a rectangular prism has two bases, top and bottom. A pyramid has one base, where edges go up to a vertex. This is called a triangular pyramid because the base is a triangle. This is called a square pyramid because the base is a square. There's other different types of pyramids as well. You might see like a hexagonal pyramid, okay, with the base as a hexagon. We're only going to really worry about these two right here. So let's talk about the square pyramid first. It's also called a rectangular pyramid. And I want you to draw it best you can. The first thing I suggest is that you draw a perfect square. And then when you draw a pyramid, draw like a point up there. And then all edges go up to the point. And then you create your pyramid. I want to talk about the dimensions that make up a pyramid. You have your edge. You have a length and a width, which in this case is going to be a perfect square, so like a 3 by 3, for example. I want us to make sure that we understand what heights are. This is called a lateral height. It's a totally different dimension, as if you were to get a true height. So if you're imagining like the Great Egyptian Pyramids, for example, there's like a door right here. You want to enter it, you go through it, and you look and you stop in the center and you look straight up. That's the true height of the pyramid. When on the outside, that's a lateral height. Two totally different dimensions. And then, of course, your length and width. The face of a pyramid are triangles. Okay? A face. Face. How many faces? I know that there's 4 faces because there's 4 sides in a square. I know there's 3 faces on this triangular pyramid because there's 3 triangular faces. Okay. Let's go ahead and draw best we can the height of the true height of this pyramid. So I kind of drew like a 90-degree angle at the bottom because if you were standing right there, it'd be a 90-degree angle. The height of this pyramid, the true height, I'm going to just say is 6 centimeters. And it's a perfect square, so I'm going to call it 3 centimeters by 3 centimeters. Let's just go ahead and call it number 1, by the way. The formula for solving for the volume of a pyramid, remember what volume is. You're actually measuring how many cubes fit inside that pyramid. How many perfect little cubes fit inside this pyramid. So if I were to take this, I want to know how many cubes fit that. So if you notice, up into the vertex, it does not fit in there perfectly. So you got to actually chop these cubes into thirds. So your volume for solving for a square pyramid is 1/3 times the area of the base times the height. So let's label that. I think you understand why we have to cut it into thirds. The big B here stands for the area of the base. So in this case, the base is a square, so you're going to use length times width times the height of the pyramid, which in this case is 6. So H is the height, true height, by the way, of the pyramid. Okay, so that was a quick review of what volume is. You're actually measuring how many cubes fit in there. Quick explanation of the formula. Let's plug in what we have. So 1/3 times the base area. So the base is the square, so that's length times width. So that's 3 times 3. All right. Times the height, which is 6. Now, remember multiplying by 1/3 is the same as dividing by 3. So if you wanted to, you can do 3 times 3 first, which is 9. 9 times 6 is 54. Now you can either multiply 1/3 by 54, or you can do 54 divided by 3. You'll get the same answer. Volume is 18. 18 what? Centimeters cubed. Remember, we cubed our answers because we want to know exactly how many cubes fit inside these pyramids. And that's number 1. Let's do another one. That was a perfect square pyramid, perfect square, 3 by 3. Number 2, I'm going to give you a rectangular pyramid. So, sort of like that. And I'm going to draw all points here. And the true height. The true height is going to be 6 again, 6 centimeters. The length I'm going to say is 7 centimeters. And the width I'm going to say is 2 centimeters. Okay. The area of a rectangle is also length times width. So let's apply our formula. 1/3 times the area of the base, the big B, times the height of the whole pyramid. So that's 1/3 times the area of the base, which is 7 times 2, times the height of the whole pyramid, 6. Let's go ahead and solve. 7 times 2 is 14. So 1/3 times 14 times 6. Okay, I suggest doing 14 times 6 first and then dividing by 3. So that would be 84 divided by 3, or 84 times 1/3. Your volume would be 28. 28 centimeters. What again? Cubes. We want to know how many perfect cubes fit on the inside of that pyramid. So those were a square pyramid, a rectangular pyramid. Okay, I want to do now next a triangular pyramid. So number 3, let's practice what that looks like. And the triangular pyramid has a different formula. That's this guy now. This whole time we've been doing length times width for the big B part. This part, we've been doing length times width because solving for the area of a square or rectangle is length times width. What's the area for solving for a base that has a shape of a triangle? 1/2 times base times height goes in this big B spot. So let's go ahead and draw it first, and then we'll apply the formula. Draw a triangle first, and then remember all points go up to the corners to create that vertex. Here's the true height. The true height, I'm going to say, is 3 inches. The base of this triangle, I'm going to say, is 4 inches. Okay. And then let's go ahead and say this side over here is going to be, I'm going to say 5 inches. Okay. You got to be able to visualize this. Using the new formula, 1/3. This is still what you're using here, but that base is a triangle. So this part, the area of the base, is going to be 1/2 times base times height, because that's the area of solving for a triangle. So that's what we need to solve for, is the area of the base. So let's plug in what we have. 1/3 times 1/2 times the base, which is 4, times the height, which is 5, times the height of the whole pyramid, 3. Now, if you're confused with that part, pause, rewind, rewatch as many times as you need to. You need to make sure you know how to substitute the dimensions in properly to the formula in order to do this successfully. Let's do what's in parentheses first so that we can solve for that area. 4 times 5 is 20, and half of 20 is 10. So 1/3 times 10 times 3. Okay? Now, all you have to do is 10 times 3, which is 30. And then you can divide 30 by 3, or 1/3 times 30. It's the same thing. Your volume would be 10 inches cubed, because you're solving for how many cubes fit inside that triangular pyramid. So those are 3 examples of solving for the volume, how many cubes actually fit into a pyramid.